Good morning, guys. So I'm just going to go ahead and go over the answers to the 5 quiz part B quiz review. So I did make a video earlier this morning. I'm not sure if you guys saw, but Google completely went down. So that video I can't find it. So just for time's sake, I'm going to go over just the answers to the evens today. All right, so for this first one here, 4 sine squared theta minus 3 is equal to 0. I went ahead and isolated sine and isolated the numbers. I took the plus or minus square root on both sides, and I used my unit circle to find the answer. So you might see these kind of cross-off marks here. That's just me writing my answer in simplest form like WebAssign might. Now on a quiz or test, I'm not going to ask you to do that. So technically the answer is 3 pi plus 2 pi n, 2 pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n, and 7 pi over 3 plus 2 pi n are totally acceptable. I just wrote them in simplest form. So if you did want to write in simplest form, it would technically just be 2 pi over 3 plus pi n and pi over 3 plus pi n. All right, let's keep on going. All right, so for question number 4, what I did first is I factored. I got it to be 2 sine x plus 1 times sine x plus 1, set both sides equal to 0, and both pieces equal to 0, and solve using my unit circle. Notice that this was a general solution, so I wrote my answer generically in green. All right, next one, number 6. First thing that I did, it gave me a hint. It said, hint, convert to quadratic type. So I went ahead and squared both sides. I did a little side note that if I said sine theta plus 1 squared, that does not equal sine squared theta plus 1 squared. What you need to do is you need to distribute the binomial. You need to use FOIL method to get a perfect squared trinomial, which is sine squared theta plus 2 sine theta plus 1. After that, I got everything in terms of one trig function. So instead of saying cosine squared theta, I wrote it as 1 minus sine squared theta, which is a Pythagorean identity. Went ahead and simplified and put all my signs on one side. I noticed that there was a common factor of sine on both sides, so I factored out a common factor of sine. After that, I used the zero product property. I set 2 sine theta equal to 0, and I set sine theta plus 1 equal to 0. That's going to give me an answer. Well, sine theta is equal to 0 at 0 and pi. So I could say 0 plus 2 pi n and pi plus 2 pi n. If I want to write that in a more simple way, though, technically 0 plus pi n and pi plus 2 pi n are the same solution. If I said 0 plus pi, and then I said pi plus another pi, those are going to get me the two solutions I already had. So I wrote it simpler as saying 0 plus pi n. After that, I have pi over 3 plus 2 pi n, and that's when sine of theta is equal to -1. All right, next one. It says, let's go ahead and solve this using inverse functions. So the first thing that I did is I factored it. I factored this to be 4 tangent x minus 3 times tangent x plus 2. And I set both sides equal to 0 and both pieces equal to 0. I went ahead and used inverse trig to get my first solution, which is theta is equal to 0.643. If theta is equal to 0.643, that's not the only time that tangent's going to have a value of 0.643. If tangent is positive 0.643 in the first quadrant, it's also going to have a matching value down here where tangent is also positive in the third quadrant. So the other solution is going to be theta is equal to pi plus 6.43. So I took 6.43 and I added an additional pi. After that, I got negative 1.07, which happens down here. If I think about it, tangent's going to have a negative 1.07. It's going to yield that value. It's going to have the same y over x value here and here. And so if I took 1.07 and I subtracted it from pi, that would be my solution there. Or also, alternately, I went on to Desmos and I picked the first I picked the first 4 values on Desmos to get my solution there. All right, so let's keep on going. So just kind of keep in mind that when you're solving with inverse trig, it's almost never going to be just one answer. The only time I can think of a solution that had one answer is if maybe like sine is equal to 1 or 0. So 1 and 0, maybe I could see that happening once, maybe not even for 0. All right, next one, number 10, I divided by 5 on both sides. Then I subtracted 1 on both sides. Sine of theta is equal to 0. That is technically 0 plus 2 pi n and pi plus 2 pi n. But if I want to write it in a more simple way, I could just say 0 plus pi n. All right, next one, number 12. What I did is I saw a common factor of cosine. I pulled that out, leaving me with cosine of theta times 2 sine theta plus 1. Set both equal to 0. I get sine theta is equal to -1/2, and cosine of theta is equal to 0, not theta, is equal to 0. That happens at, well, cosine of theta is equal to 0. If I think about where does cosine have a 0 value, that happens here at pi over 2 and here at 3 pi over 2. Technically, I could say pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n. If I want to write it in a more simple way, though, I could say pi over 2 plus pi, right? So that gets me to my next value, n. And then if I took 3 pi over 2 plus pi n, I get back to where I started with. So actually, I could just represent this generically as pi over 2 plus pi n. For sine of theta is equal to -1/2, that is going to happen at 7 pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. All right, number 14. What I wanted to do is I got everything to one side, and then I decided I didn't want to do that, and I put numbers on one side and I put trig functions on the other. I divided by 2 here on both sides, and so I want to know, when does sine theta equal, you know what, I actually messed this one up, so I'm kind of happy that that power outage did happen. Let's go back on this one. So what I'm going to get is that sine theta is equal to 1, and I want to know, when does sine of theta equal 1? Well, sine of theta actually only equals 1 at one spot here at pi over 2. And so I can say pi over 2 plus the period, which is 2 pi n, and that right there is the solution. All right, let's keep it going. Next one, number 16. First thing that I did is I replaced cosine squared x with 1 minus sine squared x. That's a Pythagorean identity. The reason that I did that is I want everything to be in terms of one trig function. Otherwise, it's going to be very difficult to solve. After that, I subtracted 1 on both sides, which cancels out that 1 on the other side. And then I saw there was a sign in common on both sides, so I factored out a sine x, leaving me with negative sine x plus 1. I set both pieces equal to 0, and I got 0 plus 2 pi n and pi over 2 plus 2 pi n. But we've seen this enough at this point that we could just write it generically as 0 plus pi n. And when sine of x is equal to 1, that's pi over 2 plus 2 pi n. And that's number 16. All right, number 18. What I did is I immediately replaced 3x with j. So I said tangent of j is equal to 1. When does tangent equal 1? Well, tangent equals 1 two places. It equals 1 here, and it equals 1 here. And so what I can say is that the angle is going to be pi over 4, and it's going to be 5 pi over 4. And this is on a closed interval, so let's go ahead and replace j with 3x and multiply both sides by 1/3 to get rid of that 3. So my total answer here is going to be pi over 12 and 5 pi over 12. Next one, 20. 2 sine squared theta minus 1 is equal to 0, so I'm going to go ahead and move 1 over, and then I divide it by 2. In order to undo a square, I took the square root, plus or minus on both sides. So I got sine of theta is equal to the plus or minus square root of a half, which is the same thing as the square root of a half, square root of 1 over square root of 2, and negative square root of 1 over square root of 2. Square root of 1 is 1, and so what I end up getting is 1 over the square root of 2, except I don't know what that is on my unit circle. But if I rationalize, if I multiply by the square root of 2 over the square root of 2, and I multiply by the square root of 2 over the square root of 2, 1 times the square root of 2 is just square root of 2, or radical 2. Radical 2 times radical 2. Those square roots undo each other, and I get 2. Well, I know radical 2 over 2, and I know negative radical 2 over 2. That happens here, 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 and here on my unit circle, and so the answer is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, number 22. What I did is I divided by 3. Same question, took the plus or minus square root. What I ended up getting is tangent of theta is equal to negative 1 over radical 3 and 1 over radical 3. Now, you could rationalize. It's probably not going to help you too much because tangent's values don't really show up on the unit circle because they're a y over x value. They're not just a y value. They're not just an x value. So what I did is I kind of experimented and saw, hey, if I took pi over 6, the coordinates of pi over 6 are radical 3 over 2, comma, a half. If I said y over x, well, y is a half over x, which is radical 3 over 2, and I kept it, and then I switched it, and I flipped it, we would see that that would yield a 1 over radical 3, which is what I want. So all of the iterations of pi over 6 are going to be solutions, and you can prove that because all the iterations of pi over 6 are going to be something along the lines of radical 3 over 2, comma half. The only difference would be if something is negative or positive. So all of the iterations of pi over 6 are going to be the solution here. All right, 24. I think I might have skipped 23. For 23, what I did is I kind of just plugged in some values that might work. I wrote cosecant and cotangent in terms of sines and cosines, and I saw that 1 over cosine x over sine x is equal to 1. And so what I really wanted to do is find out, hey, what are some values that if I plug in 1 plus something over something, it equals 1? The only solution I really could figure out would be pi over 2. If I plugged in 1 plus cosine of pi over 2, excuse me, cosine of pi over 2 is 1, and sine of pi over 2 is also going to be 1. So I'm going to get 1 plus 0. Sorry if I misspoke. 1 plus cosine of pi over 2 is 0, so I'm going to get 1 plus 0 all over sine of pi over 2, which is 1. So 1 over 1 is 1, and that works. All right, so the next one that we did, number 24, I divided by 2 on both sides. And so I just want to know, hey, if 2x is j, what's sine of j? When does sine of j equal negative radical 3 over 2? Well, I can just use my unit circle that happens at 4 pi over 3 and 5 pi over 3. But I'm not solving for j, I am solving for 2x. And so I'm going to multiply by half on both sides, leaving me with 2 pi over 3 and 5 pi over 4. All right, let's move on to the next one here, number 25. If I go ahead and factor this out, now obviously you can check all of this on Desmos if you want. If I go ahead and check this out, I get tangent of x is equal to 5 and tangent of x is equal to 1. Well, I know when tangent of x is equal to 1, that happens at pi over 4 and happens at 5 pi over 4. So notice that it happens twice, happens 2 times. The same should apply when tangent of x is equal to 5. That's going to happen. Basically, when is tangent going to be positive? That happens in the first quadrant and the second quadrant. So my first solution I got was 1.373. So that's right here. The other solution technically should happen in the third quadrant. So just to find that, I'm going to use alternating triangles a little bit. And I'm going to say pi plus that angle, which is 1.37. So my answers here are going to be pi plus 1.37, 1.37, pi over 4, and 5 pi over 4. And you could verify all of that on Desmos, and you would get the same solution, provided that you're just picking numbers between 0 and 2 pi. Next one, I went ahead, in fact, this is where it cut out. So when I went ahead and factored, I got 2 cosine of x minus 1 and cosine of x minus 2 is equal to 0. So let's go ahead and actually solve this one here. So if I get this, I get cosine of x is equal to a half and cosine of x is equal to 2. Okay, well, if cosine of x is equal to a half, let's think about that. That could happen here, and it could happen here. And so we could say that x is equal to pi over 3, and it's also equal to 5 pi over 3. When does cosine of x equal to? Well, let me graph a cosine function for a minute. The highest possible value of cosine function can be is 1, and the lowest possible value of cosine function can be is negative 1. If I plug this into my calculator, if I said arc cosine, if I said cosine inverse of both sides, I would get an error. And the reason I would get an error is because cosine's range is from negative 1 to 1. It can't give me an output bigger than 1. And so the only solutions here are x are equal to pi over 3 and 5 pi over 3. So I apologize for how brief this video was. I really wished that my video didn't get deleted, but this is the best I can give you guys this morning. So if you do have any questions, feel free to message me. I'll be, hopefully I'll have a couple of free periods today if you need help before the quiz. All right, I will see you guys tomorrow.